Dear students, this is the ninth session of the basics of differential calculus, and this will be the last session for the basics. From the next video we'll get into the textbook sums, right? If you want to see our other videos, you can just click the I button at the top. Now we'll get into the topic, right? So let me take let y equal to sine of cos x, right? Now let it be my equation 1. How will I differentiate this? Differentiate equation 1 as usual. We have tried to differentiate equation 1 with respect to x. Yes. So if I differentiate left hand side, it is 1. The formula that I am going to use here is derivative of sin x is cos x, derivative of cos x is minus sin x, right? Now if I differentiate equation 1 with respect to x, derivative of y is nothing but 1 d by d. I have differentiated y with respect to x. Right hand side, derivative of sin x is cos x, so derivative of sin y will be cos y. Sin of Adnan equal, there will be derivative of sin of Adnan means cos of Adnan. Sin of idiot, for example, will be derivative of sin of idiot will be cos of idiot. That's it. Whatever is here, I'll just put it there. Yes, sin of x cos x, sin y derivative cos y, sin of Adnan derivative will be cos of Adnan, sin of idiot derivative will be cos of idiot. Okay, right? Now same way, sin of cos x derivative will be what? Cos of cos x. Got it? Now I have to differentiate this cos x now. Okay, we are familiar whether if it is sin 2x, we'll do cos 2x, then we'll differentiate the 2x, right? Same way, sin of cos x will be cos of cos x, then I have to differentiate this cos x now. What is the derivative of cos x? It is nothing but minus sin x. Got it? Right. Now we can just like this, we can leave it, or we can simplify and we can write it as dy by dx equal to, I can just take it to the front and I can write it as minus sin x into cos of cos x, right? It is not cos x into cos x, it is cos of cos x, function of a function. Okay, right? Here if I don't put this bracket, the meaning will change, because you will think that cos of cos x into sin minus sin x, these, if I don't put this bracket, some of you may think that this cos x into minus sin x both together is an argument of this cos. It is not like that. The argument of this cos is this cos x alone. That's why I am closing with the bracket, then I am writing minus sin x. Got it? Now in order to make this more clear, we'll get into one more some problem. Let me erase it. Right, let y equal to sine of log of tan of log of tan x. Let me take this to be my equation 1. Right, sine of log of tan x. Now the formula that I am going to use here is derivative of sin x will be what? Derivative of sin x is cos x. Derivative of log x is 1 by x, and derivative of tan x. Derivative of tan x is secant square x. Now these are the things which these are the formulas we are going to use now here. I'm just skipping that step. Differentiate 1 with respect to x, we will write, right? So I'm not writing it, I'm just directly write it dy by dx equal to what is the derivative of sin x? Cos x. Sin y, cos y. So sin of this entire term. Okay, sin x means cos x, sin y means cos y. Just now I told. Sin of Adnan, cos of Adnan. Sin of idiot, cos of idiot. Right. So sin of something, cos of, put that entire term, log of tan x. Whatever is there, we should write it. Then we should close this. Now we have to come to the next function. After sine we have log, right? Now log of tan x. Log x derivative is 1 by x. Log y 1 by y. Log of z 1 by z. Log of Adnan 1 by Adnan. Okay, log of idiot 1 by idiot, right? So log of something, that is log of tan x is 1 by tan x. Yes. Now after log I have tan. Now come to tan. What is the derivative of tan x? I know it is secant square x, so we'll write it as secant square x. Right? We will just like put it together and I can write it as dy by dx equal to secant square x into cos of log of tan x divided by tan x. That's it. This is my dy by dx. Right? We'll see some more problem. Now we had last case we had two functions, sine of cos x. Right? 2 sine of cos x. Here sine of log of tan x. We saw three functions together, right? As a function of a function of a function, right? Now we will see an example for 4. Fine. Right? Let y equal to 3 root of log of or 3 root of tan of log of sin x. Right? Now here how many functions? Root of tan of log of sin x. We have 4 functions together. Function of a function of a function of a function. Right? Now let me take this to be my equation 1. What are the formulas I am going to use here? Derivative of root x is what? Because first I have root of tan. Second one only this tan. So derivative of root x is 1 by 2 root x. 1 by 2 root x. What is the derivative of tan x? Derivative of tan x is nothing but secant square x. Right? Then derivative of log x. Derivative of log x is nothing but 1 by x, and derivative of sin x. What is the derivative of sin x? Sin x is cos x. Right? Now dy by left hand side, as usual I am not writing the differentiate one with respect to x. You can write it dy by dx equal to 3 is constant, but it is in product with variable. It is not 3 plus root of, it is 3 into root of. So this 3 is in product with the variable, right? So just write that 3 as it is, then differentiate this variable. Right? Now root of x derivative is 1 by 2 root x. Root y 1 by 2 root y. Root of Adnan 1 by 2 root of Adnan. Root of Shamal 1 by 2 root of Shamal. Fine. Now so root of something, this entire term, right? So 1 by 2 root of whatever is there, we must write it, right? What is there? We have tan of log of sin x. Now next what we have? After completing root, we have tan of something. Tan x derivative is secant square x. So tan of Ibrahim, secant square Ibrahim. Okay. Yes. So tan of idiot, secant square idiot. Like that. Okay. So tan of this term, log of tan of something is there, right? So secant square that something. What is that something? Log of sin x. Right? Secant square log of sin x. So I must close with the bracket. So tan x means secant square x. So I have tan of this part. So secant square that part I have written. Fine. Now coming to the next. After completing tan, coming to log of sin x. Log x means 1 by x. Log y 1 by y. Log of Ayash 1 by Ayash. Right? So log of sin x 1 by sin x. Got it? 1 by sin x. Now we have to differentiate what? Sin x now. Log of sin x 1 by sin x. Now I have to differentiate this sin x now. What is the derivative of sin x? Derivative of sin x is nothing but cos x. So into cos x. Right? So that's it. I can simplify it as cos by sin. I know it as what? Cos by sin I know it as cot x. So I can write dy by dx equal to, I can make it simple like this, 3 into what is cos by sin? Cos by sin is nothing but cot x into secant square of log of sin x. Secant square log of sin x. Yes, what is left out in the numerator? That's it. Cos by sin became cot x. Secant square log of sin x divided by 2 root of tan of log of sin x. Yes, so this will be my dy by dx. If you have any doubts in today's session, you can just click that I button. If you have any doubts in the problems that we have seen, so this will be the end of the session for basics of differential calculus. From the upcoming video, we'll get into the textbook sums. If you have any doubts, you can just comment in the comment section below. If you can share, if you like this video, you can like, share and subscribe with your friends. If you want to get the notification of our video, you can just turn on your bell button. Thank you.